Hey, it's geometry time. So, we're going to get into some geometry today. We're going to get in lesson 12. We're looking at lines, uh, making lines that are perpendicular. So, we're looking at perpendicular, parallel once again. Continuing on with this, it's a good review of some stuff that we actually learned in algebra. But now we're moving on and doing it in geometry, and we're going to bring it all together. But let's take a look and see what we got today. So, let's see if I got my new little setup here. Did you get a chance to read that? Hey. All right, lesson 12. It's all on the line. Parallel and perpendicular. So, the image shows line in. All right, so that's the line that is already graphed for us right there. We're going to write an equation for the line that's perpendicular to n, and the y-intercept is at 0, 5. So we want the y-intercept to be right here. So we'll need to graph that after we write the equation. So if we're going to write an equation for a line that's perpendicular, remember we talked about previously that if the slope was 2/3, a perpendicular slope would be to reverse the fraction and make it opposite sign, right? So 2/3 and -3/2 would be opposite. If it was a whole number like a slope of 4, we would make that 1/4 and make that a negative, right? Because a whole number is really the same as 4/1. So when we reverse it, it becomes 1/4. So we need to find the slope of our line if we're going to make one that is perpendicular. Rise over run, right? If it's on a graph. So our rise is actually down 2. That's how much it rose from this point to this point, using 2 points that we crossed through. So -2 over, what's the run? 1, 2, 3, 4, 5, because it goes from -5 to 0. So our slope of n that they gave us is -2/5. So we need to write an equation. So our equation, remember, goes y, oops, let me raise that up a little bit, y equals mx plus b, where m is the slope and b is the y-intercept. All right, so we're looking for the slope and the y-intercept. So we're going to put y equals, we want a slope for a line that's perpendicular, so we need to reverse the slope, make it 5/2 instead of 2/5. You see it okay? Got a little bit of glare from the light, but without the light, I don't think we can see it very well. Yeah, no, that works all right. That's all right. We can do that. But I had this terrible shadow. 5/2. We'll let it adjust. We'll get there. Now, this was a negative slope, so ours is going to be a positive slope. 5/2x. And we need to cross the y at 5, so we'll put plus 5, because that would be the y-intercept. That would be the y-intercept. Y equals 5/2x plus 5. And it wants us to graph it now. So graphing that, we start at 5. It says to go up 5/2. Well, the problem is I can't go up 5 on my graph. So a positive slope of 5/2 could also be a -5 over a -2. -5 over -2 is also a positive number, right? Because it's a negative divided by a negative. So we can go 1, 2, 3, 4, 5 negative and 2 negative, and our next point would be right there. And then we could do that again to find our next point right there. So our line is going to graph right here. That is our line that will graph perpendicular to the original line in. Okay? I'm going to try this with this, even deal with the shadow. Write an equation for a line that is parallel to n and passes through the point 3, 1. So 3, 1, we're looking for that point right there. And we want it to be parallel. So it's going to have the same slope. So the slope of the original line in, -2/5 x, but we need to know where it crosses the y. What is the y-intercept for that? So from here, if we're doing the same slope as this one, which this one went over 5 and up 2 if we're going left, because we need to go see where it crosses. 1, 2, 3, 4, 5, up 2. It's going to go right there. So it's not going to cross exactly where we want it to. It's going to be just a little bit above the 2. But where exactly would that be? So what we would need to do is perhaps write an equation in the point slope form. Remember that? Because this is not as easy to tell. We could do y minus, what's our point? 1 equals our slope, x minus, and our x is 3. So using the point slope, remember it is y minus k equals the slope, and then m minus h for the point hk. To go through that point hk, we would use, oh, I put m minus h. Well, I'm going to earn stars all over the place here. X minus h. So we would take the h, subtract it from x, take the k, subtract from y, put the slope. So this works perfectly for a line that is parallel and goes through there. We could have also done the same thing on this with 0, 5. This is the mx plus b. If we wanted to do y minus 5 equals 5 halves, and this is x minus 0, so we don't need to put it in parentheses, we just put x. You see how those look very similar? Because if we add 5 to both sides, right, we get that equation. So when it passes through either the x or y being 0, either one of the axes, then it's going to look a lot more like this equation there. But let's not forget this form right here for writing a line, rather than trying to figure out exactly where it's crossing the y-axis. Don't forget we have 2 ways of doing that. So now let's look at our next thing we have to do. Our second thing, 12.2. It says info gap lines. Okay, this is one of those exercises to where we have previously in class, we'd have the cards I'd hand out. You'd have a problem card or a data card, and we'd have to work with a partner. Well, that's not going to work too well with online, so we'll do this as just a group here. So here's our problem. All right, so our problem says graph and write an equation for line N. Well, we have line R. I'll turn this back on. Woo! We have R, we have L, and we're supposed to write one for a line N. So let's see what our data tells us about it. It says it intersects R where x equals 6. Okay, so intersects line R. Well, let's see where that is. Here's line R. So where x equals 6 is right here. So this point will be on our line. All right, we see that? This point will be on our line right there. So we've got that point. So that's where it intersects line R. What's our next thing? Line N passes through the point 3, negative 1. Okay, let's mark that point. 1, 2, 3, negative 1. So we have the point 3, negative 1. And we have this point that is the point 6, 1. Those 2 points are both on our line. So we have that. And we're supposed to graph and write an equation. We could probably do it now that we just have 2 points. Let's see what the next thing it says. Line N crosses the x-axis where x is 4.5. X equals 4.5. So right between the 4 and the 5 is where that crosses the x-axis. That would make sense. Since it's a line, it's going to be straight. It's not curved. So let's connect those. It's going to go straight through there. And it looks like our slope is 1, 2 over 1, 2, 3. Our slope is 2/3. All right, so it's going to go up 2 and over 3. Our line would continue 2 and 3, 2 and 3, All right, so there is our line. We can graph our line. Now it wants us to also write an equation. Let's see what our last piece of information is here. Line N is actually a translation of line L. So if we hadn't already figured out by this point, which we could have done with 2 points, just connecting those 2 points, we can see that it is a translation of L. It's got the same slope as L does. So our equation for writing for that, we can just pick one of these points. It looks like it actually does go through -3 as the y-intercept. So we have options then. So if we're writing an equation for it, we know the slope, we know where it crosses the y. We could say y equals 2/3 x minus 3. All right, that's one option. We could have also chosen, let's say we use that first point, y minus 1 equals 2/3 x minus 6. Same line. Same line. Or if we wanted to do the 3 -1, y minus a -1. So it'd be y plus 1 equals 2/3 x minus 3. All of those are an equation for the same line because it all has the same slope. It's just using 3 different points. This uses the point 0, -3. This one's using the point 6, 1. And this one's using the point 3, -1. Any of those would be correct. One of those questions, again, where there's multiple ways to get the correct answer, which is great. We love those kind of problems. All right, the info gap. So that's what we would have done together just in partners, but we did it as a class. It's not that tricky. Not that tricky. All right, we already did page 1. Let's look at this last page here. Then we will have some problems to do that will address these same type of things, writing equations of lines, parallel and perpendicular. So if you're having any trouble with the problems, you can always come back, open up another tab in your Chromebook, go back to this video, do them at the same time if you need to. Look at the video and then, oh yeah, that's how you did this problem. And I will mention, if I haven't mentioned before, these formative assignments, these GoFormative website that you're doing assignments on, I set them up for multiple submissions, so you can go back and redo things if it's wrong. It's just your homework. It's more important for you to get it right and understand it than to get it the first time, because that's not how homework works, right? We have a chance to go back and erase and change things, and I want it to be the same way online. You can go back and change things. So, and hopefully you're printing off these blank lessons and working through some of this with me, because it's easier to write it down than to just watch it and try to remember the same thing. So, all right, line L, 3 lines, is represented by the equation y equals 2/3 x plus 3. I don't think that's still real focused real well, but it is what it is. All right, so write an equation of the line perpendicular to L that passes through this point, -6, 4, and we'll call that line P. So the most important thing we need to find out if we're going to do one that's perpendicular is what is the slope of the original line that we're supposed to write one that's perpendicular to. Well, this is in the form y equals mx plus b, and m is always our slope, right? So m is the slope. So the slope of this one is 2/3. That is the slope of the original line. So we're supposed to write one that's perpendicular. This just gives us a point. That's not a point that's on the y-axis. So I would not want to use y equals mx plus b because that's the slope and the y-intercept. We don't know the y-intercept. Let's use where we have the point slope version of a line, right? So that is y minus, what is our y? Our y is a positive 4 equals, what slope do we need to use? It needs to be perpendicular. So we're going to take this slope of the original one and we're going to turn it upside down, 3/2, and we're going to change the sign. If our original one had a negative sign, then we would use a positive slope. But since it was positive, we're using a negative slope. Now we need to do our x minus -6. What happens when you subtract a negative? Plus 6. It's the same as adding. So our equation is y minus 4 equals -3/2 x plus 6. Okay, that is the equation of our line. And this is line P. calling that line P. So now we're supposed to write an equation of the line that's perpendicular to the P that passes through 3, -2. So it gives us another point, and it's supposed to be perpendicular to that. Well, let's think about that. If we started with this line, what was our original line? L. We started with line L, and we made a line that was perpendicular to that, and we called it P. And now we're going to make one that's perpendicular to P. That should be the same slope as L, right? Because we're reversing it again, changing the sign. So that -3/2 is going to turn back over to be a 2/3, and it's going to be positive. It's going to be right back where we started with slope. It should be a line that's parallel to the original. Let's see. The equation of that line should be y minus a -2 this time. So we're looking at y plus 2 equals, what's our slope? All right, we got to go back to the 2/3 and x minus 3. Okay, well, this is N. This is line N right there. So we have line N. It says, what do you notice about L and N? Does this always happen? Show or explain your answer. Well, what we notice about L and N is that the slope is the same, even though they're in different formats. We can make these the same format by distributing the 2/3, and let's do that just to see how it compares to that one. If we take 2/3 times the x minus 3, we'll distribute it. So this side hasn't changed. Still y plus 2 equals 2/3 times x is 2/3 x, right? Because x is a variable. We don't know what number it is, so 2/3 times the x. 2/3 times minus 3. Well, 2/3 of 3 can easily break down to thirds. There would be 3 ones that would make thirds, and we want 2 of them. So 2/3 of 3 is 2, right? 1, 1, 1. We're going to take 2 of those, 2. So 2/3 of -3 is -2. So now our equation is y plus 2 equals 2/3 x minus 2. To get y by itself, we'll subtract 2, and that'll give us the equation y equals 2/3 x -2 minus 2 more minus 4. So it's going to be parallel to this one, but this one's going to cross the y-axis at a +3, where our new line is going to cross at -4. So one's going to be above the origin, one's going to be below where it crosses the y-axis at. But those lines will be parallel. Parallel. Does this always happen? Sure. Right? Because if we have a line and we take a line perpendicular to it, it's going to be at a 90-degree angle. It's going to have the opposite reciprocal slope. So then if we take a line perpendicular to that line, the opposite reciprocal slope will put it back where the original was. Yes. Opposite, let's see, opposite reciprocal of the opposite reciprocal is the original. All right, the opposite reciprocal of the opposite reciprocal would be the original. And we can look at that with any numbers we want to. Let's say the slope is 5. Okay, what's the opposite reciprocal of 5? That would be -1/5. So what is the opposite reciprocal of -1/5? When we turn it over, that's 5/1, and we change the sign to a positive. 5/1 is the same thing as 5. It gets us back to the original. So anytime we're taking the opposite reciprocal of the opposite reciprocal, it puts us back to the same number that we started with. So the slope is going to be parallel slopes. All right, are you ready for more? I believe we are, and we will prove it right here. Prove that the line AX plus BY equals C is always perpendicular to the line that passes through AB and the origin. All right, so don't give us any specific numbers. These are variables for A and B, so it could be any line, and the other one that passes through AB and the origin, that could be any line, but together they have to be the same A and the same B. and C can vary. So let's see, what would the slope be of these two lines? That's how we'll have to prove that. So AX plus BY equals C. So we're going to take that, write it down here. And we're going to rearrange that to get it in our y equals mx plus b to find out what m is. What is the slope? Well, let's subtract and move x to the other side. So we'll subtract ax. Okay, we're doing that. That will leave, that disappears over here. All we got left is by. On this side, we've got negative ax. I just put the x first because it's the variable. Plus c, the constant. C is just a constant number. The a would be a coefficient that can change. So y equals negative ax plus e by. So let's divide by b to get y by itself. So over here, y would equal negative a over b x plus c over b. So our slope is negative a over b. That's the slope of this line up here. When we rearrange it, we can see it's in the mx plus b format. Get that where it's not in the glare so bad. So our slope has to be negative AB. So what is the slope of this one? AB and the origin. Well, we can figure out the slope. Remember, it's the change in the y's over the change in the x's. How much did the y's change? The origin is at 0, 0. All right, so the slope of this, how much does it change between b and 0? Well, the change in the y's would be b minus 0. What is b minus 0? What is anything minus 0? It stays the same, right? It doesn't change. So that's the same thing as b. B minus, if we add 0 or subtract 0, it's still b. And it's going to be the difference in the x's. The x, how much did it change between a and 0? Well, if we subtract 0 from a, that's the same thing as a. So the slope of the line that would go from the origin to AB, wherever AB happens to be, the slope would be b over a. So b over a is the slope of this. The slope over here is negative a over b. Those are opposite reciprocals. And it doesn't matter what a and b is, that will always be true. So that proves that the line ax plus by equals c always will be perpendicular to the line that goes through AB and the origin. Pretty snazzy. All wrapped up real nicely, showing opposite reciprocals with any numbers for A and B. So that is all the lesson for today. Let's see, get back to getting all this technical stuff down. My son-in-law set me up with a little recording studio now, so I'm not in the middle of the dining room all the time. But we're working on it, improving our video capability. But anyway, the lesson will be online. Go through that. Like I say, if you have problems, come back and review the video. I'll be online chatting Wednesday and Thursday this week. I've decided to do afternoon, so it'll be I think like 12:30 to 2 is what I'm looking at. But you can look on Google Classroom, click on there on the link for Mr. Brock's Online, and it'll give the hours for each day. And on Friday, there's no lesson for Friday now. But this way, we decided to change this. Lessons will be Monday, Tuesday, Wednesday, Thursday, and then Friday is just for tutoring. So if you're having trouble with any of these concepts, you can get online on Friday. You can email me. I'll be online extended hours. I'll be on more hours on Friday. And then I'm also available by appointment. So if you email and we set up a time, we can get online and I can do video chat, and I can do things like this where I can actually put the paper here and we'll work through a problem together. So questions, comments, anything like that. With today's lesson, don't forget there's 2 assignments. One of them is just 4 questions, and it's for attendance only. So you do that one for sure first. Attendance, right? So it's an attendance assignment. That's why we're counting attendance for today's lesson. And then there'll be the assignment with the problems that actually is for a grade. That'll be the graded work. So look for both of those and have a wonderful day. We will see you Friday if you want to come online and chat with me.